Here's the limbic system. I've mentioned the primitive brain, but the primitive brain is often called the limbic system or mammal brain. It's in orange, covered by the larger cerebral cortex. It's the part of the brain we have in common with all mammals, including that monkey we just saw. It's true we have only a single brain, but certain parts have specific jobs. This part is ancient, 100 million years old or older, and its job is all about survival. Now, I could spend an hour talking about all its functions, but what's important to us is that it governs emotions such as fear, joy, anger, etc. And importantly, it is also the seat of most of our desires and our drives, including hunger, mate selection, and our sexual urges. You see, sexual desire, or libido, is not in your genitals. It's here. This is where you get horny. This is also where you experience the Coolidge effect. And this is where all addictions happen, including porn addiction. Here's a picture of several animals. You can see the limbic system is in dark, and on the outside is the cerebral cortex, which is very large in humans and much smaller in monkeys and rats and other animals. You can think of the cerebral cortex as the rational, logical brain, sort of like Spock on Star Trek. But it's not very emotional at all. It's the thinking, planning, decision-making part of our brain, and it comes up with the clever ideas. Now, the cerebral cortex also understands the consequences of our actions. The limbic system does not. Think of car engines. All have the same basic design. So do all limbic systems, whether it's a rat, a cat, or a dog, or us. Now, if it's hunger, mothering, mating, or sexual desire, or even addiction, it's the same brain chemicals and the same brain structures that do the same jobs in all mammals. You see, scientists aren't studying rat brains to try to figure out how to help rats. No, they're studying rat brains to help us with our addictions and our erections. And they can study them because limbic systems are so similar in all mammals. It's important to remember that the chemical balance of our limbic system shapes how we see the world. It shapes our mood. If our limbic brain is out of balance, so is our decision making. At its most basic, the limbic system is all about avoiding pain and repeating pleasure. You see, survival depends on the avoidance of pain, both physical and emotional, and the repetition of pleasure. Hot stove, bad. Ice cream, good. Mommy, good. Snake, bad. Porn, good. Well, you get the idea. Here's the centerpiece of the limbic brain. It's called the reward circuit or reward circuitry. Sometimes you'll hear the term reward center. This is so important. We're going to be spending most of our time talking about this circuit. Now, you're looking at the center of the brain is sliced down the middle, and as you can see, this is pretty small, this area. Now, this circuit is a little bit bigger and a bit more complex, but this will do. And you can see that it actually goes from the limbic system up to the rational brain. Now, this is where you experience all desire and most pleasure, such as sex and orgasm. It's also where you decide what you don't like and what you do like, and that's pretty important. It's very small, but in essence, it's running the show. You never make a decision without consulting your reward circuit. If you're addicted to anything, here's where it happened. The reward circuitry is activated when we engage in behaviors that further our survival, or very importantly, the survival of our genes. The rule is this: to do anything, you must be rewarded. So this circuit gives you feelings of pleasure, and also the motivation to seek out pleasure. In an evolutionary sense, it drives you to eat, engage in sex, take risks, and bond. It's a place where you fall in love, and it's where you fall in love with your children. It also gets activated when you're being the top dog, or your team wins a big game, or even if you're bungee jumping. The more exciting the experience, the stronger this reward circuitry is activated. But a good thing to keep in mind is it's also activated for simple pleasures like watching a beautiful sunset, a walk in the woods, or even a smile from a girlfriend. Chemicals turn on and off certain parts of the brain. For the reward circuitry, it's dopamine. It's the main chemical called a neurotransmitter that turns the reward circuitry on. The reward circuitry is the engine, it truly is, and dopamine is the gas. If you think about high-calorie foods, you actually get a bigger blast of dopamine for high-calorie foods than you do low-calorie foods. That's why they're more rewarding, or why you may crave them more. That's why you choose chocolate cake over Brussels sprouts. It's programmed. Give me high calories. Think about sugar. A sugar buzz is dopamine acting on the reward circuitry. It's not the sugar in your blood acting on the brain. Orgasm is the biggest blast of dopamine, not including drugs like meth or cocaine. Dopamine has lots of nicknames. Here's one: the craving neurochemical. It's the I've got to have it neurochemical, no matter what. You see, it's behind all motivation to do anything because the reward circuitry is behind all motivation. You're not craving ice cream or sex with that porn star. No, you're actually craving more stimulation of your reward circuitry. You don't want to win the lotto. You want to activate your reward circuitry. So the bigger the surge of dopamine in response to anything, the more you want it. Here's a question: why don't those hedge fund billionaires retire? They certainly don't need any more money. No, they want more dopamine in the form of winning at the stock market game. Here's the normal pattern of dopamine release. It looks something like a roller coaster, because in biology, what goes up must come down. It could be food, sex, even water when you're thirsty. So let's say you're starting to get hungry. Well, that causes dopamine to start rising, and then you think about a burger and it starts to rise more. Then you start making the burger and it's sizzling, and now it's starting to go way up. And right about at the peak is when you're taking your first bite. Then you take some more bites and it starts to drop, and finally it drops back down to normal levels and you're full. This graph could also represent masturbating or having sex, and the peak would be right about at orgasm. But I really want to point out that the experience of orgasm is probably other neurochemicals called opioids, not dopamine. So dopamine drives you to orgasm, but the feelings of orgasm and other pleasure are usually something else. Now, this rise and fall could also represent anything new or novel, because dopamine loves novelty. A new car, a just-released movie, the latest gadget. Heck, we're all hooked on dopamine. You can have a spike of dopamine just when you're ordering dessert, even though you haven't finished what's on your plate, because it's something new and novel. In fact, dopamine surging in your reward circuitry can override your feelings of what's called satiety or fullness, regardless of what your rational brain may be thinking about overeating or even watching porn. As with everything new, the thrill fades as dopamine levels drop. Back to the Coolidge effect. So dopamine is what is behind the Coolidge effect. If you look at our little graph here, we have female number 1 and female number 2, and the yellow squiggly lines are representing dopamine with each copulation. So what's happening is that the reward circuitry of the rat is squirting less and less dopamine with the current mate, female number 1, and then all of a sudden it can't do it anymore because there's not enough dopamine. Dopamine is behind libido. Then you drop in female rat number 2, and boom, you get another squirt of dopamine, and it comes back to work. His libido, that is. So this is what is behind the Coolidge effect, and it's also why you click onto new videos while you're watching porn, to get another big squirt of dopamine with something novel. Okay, let's give another nickname to dopamine. Let's call it the molecule of addiction. It's because changes in your brain cause changes in dopamine that lead to addiction. Cocaine, alcohol, nicotine, they all feel different, but they all flood the reward circuitry with dopamine. All addictive chemicals and activities raise dopamine levels. It's what makes them potentially addictive. Of course, you need continued use of the addictive substance or activity to cause the physical changes that lead to addiction. Here's an odd thing. We've mentioned it before. Dopamine is released in response to expectations rather than actual levels of pleasure. It's the drive to get it. It's the craving. But as I've mentioned, the actual pleasure of eating or orgasm is probably opioids. Those are morphine-like neurochemicals in the brain. Dopamine is wanting it. Opiates are liking it. Addictions are basically chasing after dopamine. So what happens is addiction is wanting more, but liking it less. Speaking of wanting and the power of the reward circuitry, here's an experiment. We have a rat, and you can see there's a wire, and then there's this electrode that's actually going to the reward circuitry of the rat. And the rat has its little paw on a lever, and whenever it hits that lever, it sends electricity, just enough electricity, to the reward circuitry to stimulate it. Now, what will happen is this rat will just keep hitting the lever and hitting the lever thousands of times an hour until it drops. It won't stop to eat, sleep, have sex, or even take care of the kids. It'll give up everything just to press that lever. As we know, this behavior is not unlike some serious drug addicts. Here's another experiment. They take the same rat, or similar rats, and they have an electric bridge between the lever and the rat. So the rat has to get shocked in its little paws to go over to the lever and press it. Well, the rat will cross the bridge and get shocked. But if you take rats and you put an electric bridge between them and food, they will not cross the electric bridge. They will not undergo the shocks to eat food. They would rather starve to death. Here's more about the power of dopamine and your reward circuitry. If you take rats and block their dopamine, they have absolutely no motivation. They will not even eat. They won't walk over to the food dish. They'll starve to death. But they still like food. If you drop food into their mouth, they'll chew it. They'll have little rat smiles, but they have no motivation to go get it. They just lie around. They won't have sex either. The male rats will have lost all of their libido. Here's a key point. You need the right level of dopamine to function normally. It has lots of jobs. Dopamine gives you that positive outlook, good attitude, keeps you motivated, keeps you happy. Just a note, many psychological problems involve dopamine imbalances, including addictions.